Hi, this is Mrs. Villette, and I'm recording a video for the rest of the sum and difference notes. If you were in third period, you've already seen this example, so you can go ahead and fast forward. The problem asks to use the sum and difference formulas for sine to establish that sine of x plus pi over 2 equals cosine of x. So as we would do with any identity, we're going to start with the more complicated side, which is the left-hand side. And I'll go ahead and apply the sum and difference formulas to that. So sine, cosine, cosine, sine, x, pi over 2, x, pi over 2. With a sign, the sign between the terms stays the same, so that's going to be a plus sign. And then we go ahead and evaluate. Cosine of pi over 2 is 0, so that just zeroes out this whole term. And then sine of pi over 2 is 1, and so we simply get cosine of x. Now the second part of the problem is to verify graphically. So I'm going to verify graphically first by graphing the cosine function. We're going to go all the way out to 2 pi here. And the cosine function starts at its maximum of 1 and ends at its maximum of 1. It hits its minimum at pi, and then it hits the midline in between. So that's the cosine function. Now the sine function, I'm going to graph that and then show how the transformation works. Starts at the origin, ends on its midline, it's on its midline halfway through, and then hits its maximum a quarter of the way through, and its minimum 3/4 of the way through its period. So this is sine of x. And sine of x plus pi over 2 means to move everything to the left pi over 2 units. So I'm going to move all of these points pi over 2 units to the left. Notice pi over 2 is the scale that I chose. So these are what my points actually end up being. And we can see that when I do that, I get sine of x plus pi over 2 is actually the same thing as the cosine function. So now we'll do an application of the sum and difference identities, and I believe that the problem that you're seeing on the screen is a little bit different from what you have on your notes, and I apologize because I don't know exactly what it says on your notes. I do know that this second part is something different, and I'm just going to go ahead and change it. Okay, so I've changed it to cosine of beta is root of 3 over 4, beta in quadrant 4. I'm not sure if that first part matches what you have or not, but in any case, change your notes to match what I have. I also know that this example 5 is not there on your notes. Okay, so we're supposed to find the sine of alpha plus beta. Let's first start by just writing out our sum and difference formula. So sine of alpha plus beta is sine, cosine, cosine, sine, alpha, beta with a plus sign between them. Now we actually know the sine of alpha. It's given right here in the problem. And we know the cosine of beta. It's given right over here. So we can actually go ahead and substitute in what we do know. 5/13 and root 3 over 4. Now we don't know the cosine of alpha or the sine of beta, so that takes a little bit more work. So we'll go off here to the side and we'll say that we know that the sine of alpha is 5/13, and since the cosine of alpha is negative, we know we're in quadrant 2. So in quadrant 2, I'm going to draw a triangle that has a y value of 5 and a hypotenuse of 13. And we use the Pythagorean identity, x squared plus y squared equals z squared, which means x squared plus 5 squared equals 13 squared, x squared plus 25 equals 169, x squared equals 144, and so x equals plus or minus 12. But we know based on the quadrant that we're in that it's negative 12. Furthermore, we now know that the cosine of alpha is the x over the r, so negative 12/13. Now we have one more value that we can substitute into our expression. Before we do that, let's go ahead and finish it off though and find out what the sine of beta is. We know that the cosine of beta is root 3 over 4, and we know we're in quadrant 4, so I'm going to draw a triangle where the x is root 3 and the hypotenuse is 4. We need to find the y. Go ahead and plug it straight into the Pythagorean theorem, so x squared plus y squared equals r squared. Root of 3 squared is 3, plus y squared equals 16. Y squared equals 13, so y is the plus or minus root of 13. Again, we know based on our quadrant whether to choose the plus or minus, and we choose the minus. And then we know that the sine of beta is the y, negative root of 13, all over the radius, which is 4. So now going back to the problem, we know that we are going to add in our cosine of alpha as negative 12/13 and our sine of beta as negative root 13 over 4. So plus negative 12/13 multiplied by negative root of 13 over 4. We go ahead and simplify, and we get 5 square root of 3 plus 12 root of 13 all over 52. Now you may wonder how this type of problem is applicable. It's a little bit convoluted. It's not something that we would do very often, but it does do a little bit of helping us review how to use the Pythagorean theorem, how to find values of other trig functions when we only know one of them and we know a quadrant, and it also gives us practice with the sum and difference identity, which is used a lot in calculus, and we'll see that not in the next example, but the example after that. So let's go ahead and look at example 4. We have cosine 5 pi over 12, cosine pi over 12, plus sine 5 pi over 12, sine pi over 12. And I don't know anything about 5 pi over 12 or pi over 12. And that's kind of the point. I don't want to evaluate these individually. Rather, I want to recognize this as the sum and difference identity backwards. So when I see cosine, cosine, sine, sine, that makes me think this is the cosine identity, and it's actually the difference identity because the sign between the terms is addition. With the cosine formula, we actually reverse them. So we say it's the cosine of 5 pi over 12 subtract pi over 12. So the cosine of 4 pi over 12. 4 pi over 12, of course, is pi over 3. So cosine of pi over 3, which is 1/2. Now, if you enter this all in one step in your calculator, you should get the answer of 1/2. But if you tried to enter any one of these individually, cosine 5 pi over 12 or cosine pi over 12, you're going to get some decimals that aren't recognizable to you. So if you enter it all in one step, you can check and get 1/2. Okay, the last example, example 6, use the sum formula for sines to find the average rate of change for the sine function. Now you have a drawing on your notes that is missing here, so I'm going to pause and draw it just a minute. Okay, good enough. The problem asks you to use the sum formula for sines to find the average rate of change for the sine function. We're going to abbreviate this AROC for average rate of change. And average rate of change is just a fancy way of saying we want to find the slope of a line that connects 2 points on the function. So we want to find the slope of this line. Well, we know that slope is the difference of the y's divided by the difference of the x's. So the average rate of change, or the slope, is the delta y over delta x. And we're going to find it between the points that we have labeled x and x plus h. So we're going to subtract the y values. We're going to be doing the function evaluated at x plus h minus the function evaluated at x all over x plus h subtract x. Now, of course, my function is the sine function, so this is sine of x plus h minus sine of x all over h. And where we can use our sum and difference formula is on that sine of x plus h part. So sine, cosine, cosine, sine, x, h, minus sine of x, and we're going to put a negative sign between those terms, all over h. And that's really all we can do. Later, when you go into calculus, you'll talk about limits and you'll let that h value get really small, but really this is all we can do. You might see a problem in MyMathLab where they want you to evaluate it for a particular value of h. So a typical MyMathLab problem might be to evaluate the average rate of change for x equals pi over 3 and h equals 0.05. So all you would do is you would plug those numbers into the expression you see above. So now that you've watched this video, you do need to work on your Unit 4 Topic 2 homework, and go ahead and get that first page completed, and you'll be sending me an email showing me how far you got during class. Have a nice day.